Hi everyone. So we have seen how to create a series object from a different file like a comma separated file and from some of the Python object. Now let's see what are the attributes and methods we can apply on the top of this series object. So we have already created one series in last video. So I'm just going to take the same series. So let me just select this series, and from that we'll create one series objects. Let me just assign it to just s only. Okay, now let's see what are the attributes we can apply on top of it. So before that, let me just print this s. So now we have a total 20 values available inside this particular series object. Now let's say if you want to know what is the indexing mechanism associated with this series object, so you can use like a s and then dot index. So it has returned as the range index kind of one object where the starting value will start from 0 and ending will be 20 in a steps of 1, because every single index has been incremented by 1. Apart from this range index, there is some hierarchical indexing are also possible, and then there is some label indexing are also possible. So in a future video we'll see by supplying some label indexing, and then we'll retrieve that index mechanism. Okay, let's say if you want to know what are the values are associated with this particular series object, you can use like a values attribute. So wherever we are not supplying any kinds of brackets, parentheses, and any kind of argument to that particular parenthesis, that means that is not a method, this is the attribute. So we are dealing here with currently the attribute. So you can see it has returned as the array, and array has total all those 20 values. Now let's say if you want to find the d type or a data type associated with this particular series object, so we can use the d type. Now we can get this from here also. So d type is equal to float 64-bit. Here also you will get the same result, like data type is float 64-bit. Now let's say what is the dimension of this particular series. So you can use like a n dimension or n dim. So it's a one-dimensional series object. Let's say if you want to find what is the size of this particular series or how many elements are there, it will return. So total 20 elements are there. Let's say if we want to find is this full series is a unique series or not. So there is a one attributes like a is underscore unique. So it's a false because it's not a unique series, as there is a 17.1 and here also it's a 17.1 is repeating, so it's not a unique series. Let's see what more methods or attributes we can apply on the top of it. So just press tab and it will give you the suggestion that what are the things you can more apply. Now there are number of methods and number of attributes you can apply on the top of it. So just by doing the practice only you will get the idea. So something like is your series is like a monotonically increasing or not. So definitely false, because see from 16 to 17.1 to again it start decreasing, so increasing and decreasing, that's why it's not monotonically increasing. Same way in case of decreasing also it will return a false. So these are the some of the attributes. Let's see couple of methods what we can apply on the top of this series object. So let me just print this as object again, series object. So now currently I have a indexing like a 0, 1, 2 up to 19. Let's say some prefix or some suffix if I want to add to this particular series indexing name. So let's say s dot we have a add prefix is there, and if I just let's say supply like a panda, or let me give the capitalized panda, so it will become a panda 0, panda 1, panda 2. So sometimes these things will be very important that you want to give one specific nomenclature for some specific series only, rather than just giving like a boring 0, 1, 2, 3 up to. So it will just concatenate it. Instead of a prefix you want to add let's say suffix. So you can just simply use like a suffix also. So it will also work same way. Now instead of panda 0, it will become a 0 panda, 1 panda, 2 panda. So whatever argument you will supply it here, it will be suffixed and it will be prefixed. Now this column is like a float values are there, so they are the numerical value. So you can apply all those kind of mathematical and statistical methods on the top of it. So let's see a couple of one. Let's say if we want to find the sum of all the values are available inside this series object, so you can use like a sum method. So total sum of all the values inside this series object is 331.45. Let's say we want to find which particular methods. Let me print it again. Now you can see all our pandas, panda 1, panda 2, what we have added suffix, it has been gone. So why this is? Because of whatever change you have applied, that is not being assigned to any particular other variable, or any modification you do that is not affected to our original series. Why this happens, we'll see into future video that is related to one important parameters available in this any of the data structure available in pandas, like an in place parameter that you want to, if you want to modify something and you want to change that original object itself, how to go ahead. So now we are at our currently plain original series object only. Now let's say if you want to find at which particular index location the maximum value will occur, so I can use the methods like id x max. So at which index position the maximum value occurs, so it's at 17. So you can see it as 17, it's a 17.29, and you can even apply like a max s. So max is a built-in Python function only, and if you just supply this series object as argument to this max function, it has written this 17.29. so this is just to verify that which is the maximum value. So maximum value is 17.29 and its indexing is 17. So that is what this idx maximum function has returned us. Now let's same way we have another equivalent methods is available like id x min method. So it's at 9th position, so 15.77, it's a minimum value available in our series object. Now let's say if you want to grab some few values, because in this case we have just the 20 values are available in our series object, so we are easily able to visualize all those value at a one shot. But sometimes you have a millions of values are available and it is not a very easy task to show all those value at a one shot. So in that case you want to grab some few values, and more often we are going to use this function either in a series object or a data frame object. So let's use it. So let's say if you want to grab some first few records, so we can use like a head method, and don't supply anything. By default it will return a 5 different series or 5 different values of our series object. Now you can see that it has returned us the 5 values from this series object. So you can think about like it has done a slicing, but it has just given us a brand new series object. So if I just assign it, let's say as head, so it's a brand new series object. If I just do as head, I just get the first 5 values only. So this head method, and there is another counter method is like a tail method. So you can use like a tail, and if you don't supply anything from the last, it has returned us the 5 values of this series object. And here also it has returned this brand new series data structure. Okay, so it is just by default returns the 5 values. Let's say if you want to grab only 2 values sometimes, okay, same way you can apply like let's say from the back side you want to find, let's say 10 values. So last 10 value it has returned with brand new series data type. Now let's say some more statistical function what we can apply on the top of it. So let's say s dot, if you want to find the average value of every single values available inside this series object, so we can use the mean method. So average value is 16.57. If you want to multiply every single values are available inside this series object, so it's 2.42 into, it's in a scientific notation, so it's into 10 raised to 24. So it's a very big number. Let's say if you want to find the standard deviation of this particular series, so you can use the STD method. So it's a 0.40. So the amount of deviation from the mean overall from your center point, you can say mean is like a center point of your data, it's around 0.40 in this case. Let's see what more things we can apply. Let's say some attributes. So we haven't seen this particular attribute like a shape. So shape is return us the 20 values. So there is a 20 values are available, and after comma it has not written anything because it's a one-dimensional object. So when you're dealing with a data frame and you apply this shape attribute on the top of it, so in that case you will get number of columns also. By default here the number of column is 1 only. Apart from that, there is one more method like a describe. So let's see what describe will return us. So describe, we have individually calculated this mean, product and standard deviation count. So this describe method at a one shot will calculate every single thing. So provided that this series object should be of data type like a float or integer only, because all those operations you can apply on the top of numbers only, that's why. So there are total count is 20, mean is 16.57, this is what we have got it here. Standard deviation, minimum value and quartile of 25%, that means 25% of value inside this series object which is less than 16.32, and 50% of value which is less than 16.46. But other way around also you can think like a 25% of value which lies between 16.32 and 16.46. Maximum value is 17.29. So we have seen a couple of methods and attributes what we can apply on the top of this series object. So that is all about this video. We'll see some more detailed functionality what we can apply on the top of this series object in the next video.